Deoxyribonucleic acid contains your genetic code, DNA, a molecule that makes up all your chromosomes. Double helix structure, a two-stranded spiral. Set of instructions for your cells so that they know what to do, like send their signals and make new bonds. Making proteins from acid to amino. Complete set of genetic instructions is a genome. Nucleotides exchange and have the things that they're composed of phosphate, nitrogen base, and deoxyribose. Each nucleotide base is made up from these small adenine, guanine, thymine, adenosine, and that's all. A always pair with D, and that's the base parallel. C always pair with G, and that's the way they go. Deoxyribonucleic. DNA is deoxyribonucleic acid, yeah. Deoxyribonucleic. DNA is deoxyribonucleic acid. These complementary bases, each on opposite strands. You can remember the pairs, both a mnemonic GCAT. Telecontrol complex process to make a protein from a gene. It goes transcription and translation, two major steps in the journey. Transcription takes information, transfers to mRNA. Messenger moves the nucleus and onto the next stage. This is called translation. Happens in the cytoplasm. Ribosomes read the code out. tRNA makes proteins one amino at a time. Deoxyribonucleic. DNA is deoxyribonucleic acid, yeah. Deoxyribonucleic. DNA is deoxyribonucleic acid, yeah.
20 minutes later.
Cool. All right, I've got some people that are done. All right, cool. You did fine. Okay, so let me get my camera ready. Cool. All right, so let me get this all hooked up. All right, so in fourth period, this was the last thing that we looked at in fourth period. And this was rabbit cells. So since we're already here, so remember I said that in the individual tissues that you see, there's hundreds of cells. Well, there they are. Look a little bit closer. And those individual little circles that you see are nuclei in the cells. Oh, hooray, Alima. Yes, these are individual cells. Let me go in a little bit closer to 40 times. Give me a second. Whenever you go up in magnification, you have to slow down. There it is. These are individual cells right here. And then those dark purple spots are the nuclei. Mm-hmm. It's cool. All right. So what else did we look at? We looked at blood. So when we looked at it underneath the zooming microscope, um, we could see them, but not so well. This is probably all we could see. Probably not even that well, right? So let's zoom into 10. And this is what they look like. Remember I said that red blood cells don't have a nuclei. As a matter of fact, what they do is that once the red blood cells mature, they will actually get rid of their nuclei. They'll actually remove it from their cells once they are mature. They do look like Cheerios. And if we go to 40, there they are. And if I slow down and move like across, you might see a white blood cell or two. Tapioca pearls. Ooh, now I want boba. Now I want some boba tea now. There's one. There it is. That is a white blood cell. Oh, and there's some more right hanging out. All right, so we also looked at nerve tissue from a pig. All right. Give me a second to find it. There it is. These are what neurons look like. So if I zoom in just a little bit more, if you see those big purple blobs, those are actually neurons. Kind of look like one student not a long time ago, but a few years ago, about 4 years back, when we were looking at neurons in anatomy, he said that this tissue looked like nerve tissue looked like cotton candy to him. And I was like, that's a great way to describe it. It does kind of look like cotton candy. So these are individual neurons, this right here. And you'll see the nucleus inside of it. But what are all these little black dots all around? Well, that too is a part of the nerve tissue. But they're called glial cells. And what they do is they attend to and they take care of the nerve cell. So if the nerve cell needs nourishment, if it needs repair, if it anything that nerve cell needs, there's like 5 different glial cells that will actually take care of that nerve cell. So, oh, they do look like little fish. Yes. So this is a neuron, and these smaller cells around it, you can see their nuclei are known as glial cells. So I like to think of the neuron as the bride, and all of those smaller cells around it, the glial cells, are like the bridesmaids, and they pretty much take care of everything that the neural cell needs, or the extensions. Why are they so much bigger, or is it the dye's effects? No, I think that's their size. I just think that's just how they look. I mean, they were alive at one time. What else do I have? Ah, cheek cells. I'm pretty sure they were very much alive before they prepared them. Before they prepared the slide. This glass. There they are. Cool. These are cheek cells. Some of them are just kind of globbed together, just on top of each other. That's just how they prepared it. But yeah, these are what your cheek cells look like. And so it's a little bit closer. And then you'll kind of see that there's like some dark material inside of them, like little black dots. Like this is a nucleus. So all those individual black dots are the nuclei. And skin cells kind of form in sheets. And when they come off, they kind of come off as flakes when they come off your body. And if we look a little bit closer, there they are. That's a good shot right there. How do they get these cells? When they die, or do they just float around the body? I mean, it's just like taking a blood sample from someone and then putting it on a slide, or taking cheek cells like right then and there from someone and just putting it on a slide. You're just preserving it. That's all you're doing. So these are human cheek cells, and you can literally just like, if you want to, if you have your own microscope, you can actually look at your own cheek cells right from your mouth. I'm pretty sure that's the same way that they do it. So you can just take a toothpick from the inside of your mouth and just kind of move it around in the corner of your cheek, and then make a slide just like this in real time. I'm pretty sure that's kind of how they do it. Yeah, I don't think they're. I mean, if you think about it, there are a lot of people who are sick in the hospital, and they have certain organs removed, or whatnot. And when those organs are removed, they probably use them for scientific research. Because at that point, I mean, do you really want your diseased um, tonsils? Do you want them, or you just want them gone? So more than likely, they use them and they study them. So, and cheek cells are easy to to cultivate. Like, you can do that from home with a little bit of iodine and a microscope slide and a toothpick, and they look just like this. What else would we like to see? We got like 3 minutes. Skittles are made of cells? It's a new one for me. These are dog heart muscle cells. You have three types of muscles in the body: skeletal, smooth, and cardiac. So you have three types of muscles, and they all kind of look a little different. So, skeletal muscle kind of looks like steak, smooth muscle kind of looks like waves, and then heart muscle is very, very thick, and there really is no rhyme or reason to it. Yeah, so muscle looks different. That's heart muscle. And then I had some really good onion cells, but I can't find them. Oh, wait a minute. I got 1 minute. Oh, why? Let's see. Where are my onion cells? That would have been nice. There it is. Onion epidermis. One more for the road. There it is. This was the cells that you saw on my YouTube channel. Now these had to be stained this way because onion cells are clear and they have to be stained so you can see them. So you can clearly see the cell wall and you can clearly see the nucleus in these. And you can probably, if I look in very closely, you might be able to see a central vacuole. You might be able to. The central vacuoles are easy to see too in plant cells. Yeah. I think this is the central vacuole. So skeletal muscles look like steak because it's layered. Yeah. And they divide on top of each other. Mm-hmm. Yeah. All right, it is 1:46. It is time to go. I'll see you all tomorrow. We'll review a little bit more. Thank y'all so much. Y'all are a joy. Bye. All right, children, class is dismissed. Bye. Bye. Have a good one.